Hey everybody, today I'm going to be doing a continuation of my last video where I set up this integral and the whole parameterization for this complex integration thing that was inspired by Michael Penn's video a few months back. So if you want a whole refresher on what just happened, I recommend just watching my video from last week and then you should be all caught up. So this is where we are. We have to compute this integral from 0 to ln2 of this crazy expression with complex numbers and all that. So let's just get started. So basically, I could just do an easy u substitution, but that defeats the whole purpose of this because we're trying to show that in the end, like whatever parameterization of integral of z dz we do from 0 to 1 plus I, then we get the same result. So doing a u substitution will basically just get us back to where we started. That just defeats the whole purpose. So let's just, actually, we're going to do it the long way and FOIL all this out, multiply everything out, and then do whatever we need to do from there. So, first, let me just multiply everything out, so I'll probably just speed up the video at this point. Okay, so this is what we have. Everything should be straightforward, except maybe this term. This term might be a little confusing. I just took this and multiplied it by that, and so we get ln2, or like 1 over ln2 times 1 over ln2 gives us 1 over ln squared 2. And this minus sign comes from I times I, since that's just negative 1, and then the t just comes along at the end. So that should explain that. Everything else should be pretty straightforward. So now what we're going to do is we're going to notice, let's just look what's easy, what's not, because we got a lot of terms here. This is easy to integrate, that's just a simple u substitution, super easy. We're going to have to use some integration by parts there, so that's not really that easy. This is easy because this is all a constant multiplied by e to the t, so that's cake. We can actually combine this one and then get something, something a lot simpler there. This is a constant, which is easy to multiply. This is a constant times t, which is, to integrate, this is also easy to integrate. So everything except this term here is easy to integrate. So what I'm going to do is I'm going to split this up into three integrals actually. One with this, this, and this, so this and these three. Another with this guy, just so we can do a quick substitution with that. And then this, we're going to have to use integration by parts, so I'll save that for its own integral. So that's all I'm going to do, and I'm just going to reorganize that. Okay, so this is where we're at. I put that negative sign up there, those two are negative. This, I took the e to the t from this term and this term, and I factored it out so that we had this constant times e to the t. And then I put this in its own integral, and this in its own integral. I factored out the 1 over ln2 times I, because that's also a constant. Just factored that out of the integral, so we don't have to deal with it then. So yeah, let's compute this integral, and then let's do the substitution. Actually, I'm not going to compute this yet. I'm just going to put this down here, just so that we'll compute all the integrals at once. I'm going to figure out the substitution here, and then I'm going to do the u sub here. So, what are we going to get? So, let's see, we get, oh wait, I meant integration by parts. So, I'll just use w for this variable of integration. So let me just draw boxes here, just so we know what we're doing. So w is just going to be equal to 2t, and then dw divided by 2 equals dt. That's just, you should probably very easily get that at this point. And then for this guy, the integration by parts, we're going to need a u, a du, a dv, and a v. So e to the t, it doesn't matter where it goes, whether it's u or dv, it's not going to make a difference. The t, if that's being integrated, that's more complicated, but if it's being differentiated, then we're left with dt. So that's super easy to deal with. So that means that dv is e to the t dt, and then v is just e to the t. And that's it. So that's all that, that integration by parts. Very easy. So yeah, now let's, what this is going to give us is, so we're going to go down quite a bit. What this is going to give us is basically that we have this expression plus the 1/2, because that 1/2 comes from here, times the integral from, so then w whenever t equals 0, w equals 0, and then when t equals ln2, then w equals 2 times ln2. And then we just have e to the w dw. And then we have this guy. So we're factoring out the 1 over ln2 times I from the whole thing. And then I'm going to pull that out. And then we're going to take, so uv, so that's t e to the t. Evaluate that from 0 to 2, no, just 0 to ln2. And then minus the integral from 0 to ln2 of, so uv minus integral of v du. So that's just going to be e to the t dt. So that's it. E to the t dt, and that's it. So that's actually not that difficult. So now we're going to evaluate all the integrals down here at the bottom, and then we'll see what we get. Okay, so I evaluated everything. It should be pretty straightforward. They're pretty easy integrals. This comes from that. This guy actually directly comes down here. There's a 2 down here because integral of t is t squared over 2, so that divided by 2 goes down there. This guy basically just stays the same, and we're going to evaluate that. This is just integral of e to the w, so that's not any different. This, I just brought this guy down so we could all evaluate all these at the same time. This is also very straightforward. And so yeah, that's all the integrals just integrated. So now we're going to evaluate them, which shouldn't be too difficult, but yeah, I'm just going to do that now. Okay, so let's continue with the evaluation. This is the part that I have to be really careful with because I mess up a lot. But yeah, so let's get started. So ln2, so let me just group everything in parentheses. So we're going to start with ln2. We're going to put it all in here. So we get minus 1 over ln2 times I times ln2. So those ln2s are going to cancel. So we get minus I. We put ln2 into t, so we get ln squared 2 here, and also down here, those cancel out, so we get minus 1/2. And then we put ln2, it's going to go up here, so e to the ln2 is just 2, so we take 2 of these, so we get, I'll just put it 1 over ln2I, and then minus 1. Okay, and then we're going to subtract off the 0, so this becomes 0 because multiplying by 0. And then we have to see here we get e to the 0 is just 1, so we just take this guy, 1 over ln2I minus 1. Okay, and now let's take this. So we get 1/2 of, so e to the 2 ln2, that's going to be 2 squared, which is 4, minus e to the 0 is just 1, so that's that. Then we take 1 over ln2I. Alright, this really isn't that hard either. E to the ln2 is just 2 again, so we get 2 times ln2. Okay, and then we take minus 0, that when we plug 0 for t, then that just becomes 0. So we take this minus this guy, so e to the ln2 is just 2. That looks like a z. It's just 2. And then we do a minus with another minus, so that's plus. And then we get e to the 0, which is just 1, and that's it. So now let's just simplify some of these things. So we get negative I minus 1/2 plus 2 over ln2I minus 2 minus 1 over ln2I plus 1, because that minus and the minus. And then we have plus 1/2 of 3, so that's plus 3/2. And then we have, I'm going to distribute this, so when I distribute this ln2, and that ln2 are going to cancel out, so we get plus 2I. And then we get minus 2 over ln2I. And then we get 1 over ln2I just multiplied by 1, so I'll just add that. Alright? And so now we can simplify everything, so not too difficult. So we get this 2 over ln2I as well as that one cancel out. This 1 over ln2I and this one cancel out. We see here 3/2 minus 1/2. So 3/2 minus 1/2, that's going to be 1. And then we have, yeah, so 3/2 minus 1/2 equals 1 plus 1 is 2, but then we have this minus 2, so that, all those guys turn to 0. and then we have 2i minus I, and that is equal to just 1i. So after all of this, this is our final answer. And this is what I wanted to get, because this is what Michael Penn got in his other two examples of doing the same integral with two different parameterizations. And so for me to get this through all that work, yeah, this is what I wanted. If I didn't get I, then I would have been upset. But yeah, so that's pretty much the end of the video. I just wanted to show you a cool little way that you can first of all think of how to parameterize things, and then second of all actually execute them without using easy rules, because like we could have just done the U sub at the start, but we couldn't, because then we'd just be back to where we started. So thank you guys so much for watching, and I'll see you in the next video. Bye guys!